Gentlemen, behold, freedom unleashed. Yeah, this is literally the Freedom Unleashed CPU from SiFive. It's a RISC-V CPU, and it's open source, and this is big news. You can get a RISC-V board like this today to experiment with. You know, Debian Linux is basically fully operational, and this dev board has gigabit Ethernet, USB, and micro SD slot. We've got 8 gigs of onboard RAM with error correction. This is a quad-core, 1.6-ish gigahertz CPU on a 28 nanometer process. It also has this high-speed expansion slot on the back, which will let you interface with, well, whatever you want to. If you want to develop, PC-type applications, there's an FPGA-powered board available from Microsemi, whatever, that will give you USB and M.2 and PCIe expansion. You can run Quake 2 on this thing, and it'll run pretty well at that. Now, at the end of the day, is this just another embedded CPU? What's the news here? Surely this is a glorified Raspberry Pi or a Tinkerboard or Oodroid or Latte Panda or something like that, right? Well, there's this whole RISC versus CISC debate that I really don't want to get into. Modern CPUs they're just stupid complicated. And it doesn't always make sense for applications that those CPUs might be used for to target that. And so at the end of the day, the architecture doesn't really matter. And it doesn't matter for architectural reasons, at least, and I'll explain that in a second. What you have to understand is that the next breakthroughs are likely going to be around custom silicon. You're probably already a PC enthusiast, and look what's happening around you. Gains in x86 have been around adding more silicon for things like H.264 decode and vector units and AVX 512. Not really improvements to the base x86. You can only do like a memory copy so fast. And there's lately been AMD Zen, which is an entirely new microarchitecture, but it took a lot to get that right and compatible. Now look at NVIDIA. The new RTX graphics cards, they have an insane amount of silicon. Look at the shaders and the vector units, you've always had those, but now you've also got tensor cores and lots of other stuff in these giant pieces of silicon. Finally, after decades of Moore's Law, the lowest hanging fruit really is custom IC design. But custom IC design is not accessible, nor is it really standardized. I mean, we've got everyone who wants a custom IC reinventing the wheel with like a machine learning accelerator or memory controllers or, but those are really the bog standard components of a system on chip. So what do? It's like, well, enter SiFive. You can sort of Lego some stuff together. Now, there are field programmable gate arrays, FPGAs. You may have heard of these. These are cool because you can write a piece of software that configures the hardware inside an FPGA chip, and then the FPGA will behave exactly like a custom circuit. So you can even do a custom CPU this way. The best example that I can think of that you might be familiar with is the FPGA module in high-end NVIDIA G-Sync monitors, like the one from Asus. The time to get that FPGA implemented in custom hardware was just too long, and NVIDIA's G-Sync partners like Asus shipped a $400 FPGA in their displays. And you mean to tell me there's no ecosystem for rapid development of custom silicon? And we shipped a finished product with FPGA? No. And that's why Asus and NVIDIA are shipping a $400 FPGA module in consumer G-Sync. Now, don't get me wrong, FPGAs are great for prototyping and experimenting, but they should definitely not be in mass-produced products. This type of thing is a possible business opportunity for SiFive, and that's probably why NVIDIA is a partner of SiFive. Now, if you want a custom 16 nanometer IC, sure, got $50 million laying around? That's about what it costs. Look at what AMD does with their Zen CPUs, because they've been kind of open around it. They fly around the world twice, basically, from fab to binning and packaging. It's around the world to the US, China, Taiwan, Germany, partners like Global Foundries and TSMC. It's just not a simple operation at all. And, AMD is a relatively small company compared to NVIDIA and Intel. Now, what if you could pick and choose IP components from several vendors online and, sort of a la carte your way to a CPU for whatever your industrial application might be, and you could get it in a matter of weeks or months? Well, that's SiFive's vision, as I understand it. And it's also open source, but open source, what sense does that make? Why would you open source all of this complication and proprietary stuff? Well, open source does actually make sense. But you're going to have to peel back the layers here a little bit to understand what open source really means in this context. So let's talk about Amazon for a second, because Amazon AWS and their use of open source. I guess AWS is redundant. Amazon Web Services. I mean, look at it. Jeff Bezos's moneymaker is Amazon Web Services. It's not you buying books online or anything like that. AWS was built with open source tools, and a lot of improvements to open source tools have come from Amazon. AWS just wouldn't have been possible without the community plumbing of open source software that's powering all of that infrastructure. One might say that Amazon also reinvented the whole infrastructure as a service business model because of the kinds of things that they made available to the public through their API and what eventually became Amazon Web Services. AWS enables a whole new kind of business. Just a handful of people could launch an app with millions of users. AWS is under the hood of a lot of success stories in software startups for sure. So SiFive thinks they can accelerate new product development and hardware the same way that the AWS API software stack has been transformative for those businesses. You can design a new CPU, but automatically be sure that it's compatible with, say, Samsung's RAM ICs, because you've used known, good, and tested IP when putting together your system on a chip with SiFive. So how do you put your own custom SoC together? Well, SiFive is putting all of that on the web. It's mostly a GUI chip designer where you can pick the components that you need, machine learning or vision processing or high-speed interfaces, memory controllers for whatever your particular application is, you name it. Whereas if you think about AWS, it's now possible for a small company with just a few employees to have millions of users at $1 billion valuation. Instagram. So now we've got commercial projects that can launch the same way and have this insane compatibility with other companies' IP offerings, not just small time people, but RAM compatibility and AI accelerators and vision processing and all the bleeding edge stuff with a little bit of custom silicon. And since silicon is not really getting much faster for compute, SiFive wants to be at the center of this new low friction and fast ecosystem that accelerates custom chip creation with RISC-V at the computational heart of the platform. So think of it, RISC-V is kind of like the kernel that's going to bring together this worldwide IP from many different companies, the way that the Linux kernel brought together all of the GNU utilities to really make something special. So RISC-V offers the base computational instruction set architecture, which is actually pretty old and very robust, but it can be extended for your custom ICs, almost like Lego, with other IP from other companies, even your own custom IP, that's all your own and totally you, because it's all open. If you run into a problem with whatever custom, new, awesome, innovative thing that you're working on, you have all of the tools and transparency that you need to understand and troubleshoot the situation. Now, SiFive has a lot of partners in this, and I mean a lot. I mentioned NVIDIA, but also Google and Western Digital and over 100 more companies, giants in the industry. And when you look deeper for a sec and look at the open source stuff that Google has been doing with TensorFlow and NVIDIA with NVDLA, the deep learning thing, then it maybe starts to make more sense why SiFive is doing this as an open source thing and why those companies are opening their IP in hopes that it will be incorporated into future products. And I'm given to understand that there are folks right now today working on NVDLA on RISC-V right now. It really is an open source CPU. For me, and this is key, in the end, it doesn't matter what the architecture is. What matters is the infrastructure around the CPU. For Linux, x86 doesn't matter. It's everything around x86, the peripherals, the support, software, compilers, all the other people. But SiFive gets that, which is why the partners in the ecosystem is so important to them. They need all of the support and all of the people doing the adoption. It's not about the instruction set, not really. So don't fixate on the instruction set. It's how easy this is going to be to adopt and use and get up and running in your product. If the RISC-V infrastructure makes it easier to adopt, easier to get products to market, and easier to support products in the market, it will be very quickly pretty much everywhere. Kind of like Linux. And I'm sure like Linux, we'll see, the year of the RISC-V desktop. No, I don't think we're going to see that anytime soon. But also like Linux, it doesn't mean that we won't start to see it pretty much everywhere else, because Linux is pretty much taking over the world everywhere. And it is a grand vision of the future of embedded and customizable compute that SiFive has. And if they're right, they are poised to be the next Amazon of this niche, whatever, as they reinvent how this works in a whole ecosystem. Now, next video, we're going to take a look at this expansion board for micro-semi and some of the other things we can do around RISC-V. So this is an FPGA, it gives us an interface for the high-speed, chip link thing. And then we've got PCI Express and M.2 and USB and SATA and all sorts of fun things. And this, plus a graphics card, is what we need to play Quake 2. That's been a quick look at RISC-V and my impression after playing with it for the past several weeks over the holiday. It's exciting. It's an exciting time. They're ambitious. Oh, they're ambitious. But it's exciting. It's fun. It's a new thing. So if you have any ideas or stuff you want to try, or run some benchmarks and do some stuff. I mean, benchmarks aren't really all that super interesting because how fast do you really need? It's not about how fast. It's not what we're talking about here. But anyway, I digress. I'm gonna go hang out on the Level 1 forum, and so if you want to come and gush over RISC-V, you should come to the Level 1 forums. I'm Wendell, I'm signing out, and I'll see you there.